You are welcome to my channel. I am Adewale Fashi and I'm a GMAT quant instructor. I've been doing this for 4 years and now my plan is to begin to put up GMAT focused questions to solve, and I intend to make it a very long series. So you are in for a very long ride. Now, the question you have on your screen is under the topic pipes and cisterns. It's a type of work rate questions. Now, rate questions are usually very tricky, and this one is the difficulty level is hard. So usually when you hear that the GMAT question is hard, so people think it involves complex mathematical calculations. No, the difficulty level of a GMAT question is dependent upon the number of concepts tested or the number of steps you take to arrive to solve the problem. So let's look at this particular question. Now, there are so many ways you can solve this question. Now, some will take you through very long algebraic calculations, but there's a particular method that will help you solve this particular question within a very short time. And you know, with the GMAT, if you're able to solve a question within a short time, that's very wonderful, because when you are taking a standardized test, your accuracy on any question is very important, and also timing is also very important. So let's take a look at the question together. A filling pipe can fill an empty swimming pool in 4 hours, while a drain valve can empty the full pool in 5 hours. Now, normally when you want to solve this kind of a question, learn to take note of every detail in the question. So from this first sentence, you will see that something is happening here. You have two pipes. One is filling the pool, one is draining the pool. So what that means is that both of them are working in opposition to each other. So the next sentence says, to fill the empty pool, the filling pipe was opened at 1 p.m. and after some time, a drain valve was also opened. Second sentence. Now the filling pipe was open for a period of time. We don't know what that time is. And then the drain valve was open. So after the drain valve was open, the filling pipe was still pouring water into the swimming pool. So you must take note of that. So the last sentence says, if the pool was filled at 11 p.m., when was the drain valve open? It is very important to take note of what the question is asking of you. So it's a common error for students to be solving for a different problem while the question is asking you to do something else. So the question, we are asked to find the time when the drain valve was open. So I'm going to take you through a very short method of solving this kind of problem. But first, let's calculate the rate of each of the pipes. So let's say the filling pipe, that is rate 1. Now, since it can fill the pool in 4 hours, the rate will be 1/4. So the 1 being representing the volume of the swimming pool and the time taken. So the formula for rate, every rate type question is given by the formula amount of work done over time taken. So the rate of the filling pipe is 1/4. So from the question, so while a drain valve can empty the full pool in 5 hours, so the rate of the drain valve is therefore 1/5. So now, if the filling pipe was opened at 1 p.m. and then later on the drain valve was open and then the swimming pool became full at 11 p.m., that's about 10 hours. So the formula we are going to employ in solving this question is the amount of work done by the filling pipe. Let's say it is pipe A plus, no, we are not going to use plus now, because you know I said earlier on that taking note of detail of the question is very, very important. So the pipes are working in opposition, so it will be minus amount of work done by the drain valve. so equals 1. So from here, if the rate is 1 over 4, so like if you have rate, general rate formula, amount of work done over time. So that means work will be equals to rate times time. So now the amount of work done by the filling pipe. The filling pipe was in operation for 10 hours. So time times rate. The rate of the filling pipe is 1 over 4. Then you multiply that by time. It was in operation for 10 hours. Minus the rate of the drain valve is 1 over 5. How much time was it in operation? We don't know. We were not given the question. And then we are not even about to guess. We can't assume. So you have, let that time be A. The amount of time the drain valve was in operation. So everything equals 1. So this will give us, this is 2, this is 5. So you multiply everything by 10. So that will give us 25 minus 2A equals 10. So from there, we can now go ahead and solve for A. So this is minus 2A equals minus 15. So this is 15 over 2. So that means A equals 7.5. 7.5 hours. Now 7.5 hours is 7 hours 30 minutes. Now what does A mean? Because when you generate a variable, it is important to understand what it means. A means the length of time within which the drain valve was in operation. The question is asking us, when was the drain valve opened? To find when the drain valve was opened, you just subtract 10 from 7.5. So 10 minus 7.5 will give us 2.5. 2.5 is 2 hours 30 minutes. So 1 p.m. So that means the filling pipe operated from 1. So 3:30. So 3:30 p.m. was when the drain pipe was opened. So that makes answer choice D the answer. So that is it. So you can see the calculation is quite short. So if you know exactly what you are doing, this should take you less than 30 seconds. And then you pick your answer, move to the next question. So if you like what you see, you can go ahead and like my channel, and then drop some comments if you feel like. And then if you want to contact me, my email address is adewale.fashipe2020.com. So hope to see you some other time. Bye.